I'm here representing GeoSLAM. So I work for Surveytech. So we are the UK main dealer importer of GeoMax products, but we're also in the UK, we're the main dealer for GeoSLAM products as well. So we've my background, as I mentioned earlier on, I've been working now with Point Cloud since about 2002, 2003, when they first commercially came on the market. The technology was available, and I was very fortunate to get in at that very early stage. And it's been a fascinating sort of journey to see the technology transition from very, dare I say it, primitive initial data capture tools right through to where we are now with mobile devices. I've had primarily my experiences when I was working on the tools as a surveyor was within the sort of tripod world of scanning, so the static world. But with GeoSLAM, obviously our primary focus is within this mobile capture, so being able to use handheld technology, handheld LiDAR to map the spaces. So yeah, it's an interesting application base, and we're starting very much to see a transitional shift in uptake of GeoSLAM and SLAM technology generally, and seeing it fitting in and being very complementary to tripod-based systems. So for those of the uninitiated in the market, we'll have a quick look and dig into what SLAM is essentially. So SLAM is your simultaneous localization and mapping. So what we're doing is we are constantly viewing and mapping and using geometry objects within that scan data to be able to, obviously, within that view of the scanner, to be able to form and position and create mapping technology. There's some real key benefits with and where we're seeing strong application base of SLAM technology. It is an incredibly rapid way of capturing data. We're able to essentially, as fast as we can walk steadily through a building, we are also digitizing that space, and we're capturing 3D coordinate point information. It's very simple. So we have a lot of non-survey users being able to adopt GeoSLAM and SLAM-based technology applications very, very rapidly, which lends itself to MOD applications and police forensics applications. But we do also obviously have this niche within the survey community as well, which fits in with the tripod-based systems. And the versatility, we can map pretty much anything with the systems. There's two primary technology hardware functions that we have with two different, a shorter range solution and a longer range solution. We'll talk about those a little bit later on. But with the longer range solution, we're not just an indoor mapping tool. We're seeing it extensively being used on backpacks, vehicle mounted solution, as well as obviously still the handheld mapping ability as well. So how does SLAM technology work? And as I said, we're robust in how we capture. The visibility of the scanners is key. It sees what you see as you move around that space, and provided you give the technology the ability to see and view what you can see, then we're constantly mapping, and we're using all of that geometry that we're capturing to be able to unravel and process our SLAM data. But the key for us is being robust in our capture. We can see that as we walk around, we form loops within the data, and that gives our SLAM trajectory rigidity, and it gives it structure, and that improves the quality of our data. Early systems, drift was a common factor where it didn't quite have that ability to be able to fix itself and move and use existing data. But now obviously we've got 16 sensors within the Horizon scanner, and all of those sensors come together to help us produce a nice robust data set. And as you can see, we are in that walkthrough. So we end up with our red line, our trajectory line, which is nice and repetitive. We've got commonality as we move around that building. But what underpins the GeoSLAM technology is the beam, the GeoSLAM beam algorithms. This is the software base that actually does that complex unraveling of our data. So with mobile technology, the scan head itself rotates as we're capturing, and it has a walk line to our trajectory file. And what the technology, this algorithm is doing, is essentially unraveling that helicoid of data from being a spiral to being actually what we would recognize as a traditional point cloud. So the beam algorithm has been enhanced and developed, and the new version of GeoSLAM Beam, which is in the latest release of GeoSLAM Connect, is a really, really strong offering on the market. It's robust, it's reliable. We've got data sets that are processing with great accuracy that previously may not have processed particularly well. So those enhancements obviously improve the confidence and the application base of use of SLAM technology in the market. So what is the key differences then between the static market and the mobile market? So obviously tripod-based systems, we work on line of sight data capture. Mobile systems, we go everywhere with the scanner. So we are constantly capturing as we walk and move through those spaces. So a quick example here. So with static scanning, the little orange dots that you can see within this building floor plan essentially represent every single tripod location. So we've located our scan, we've taken our measurements, we've done that scan, we've moved to the next location. And we can see that to do this building properly, we've got somewhere in the region of 125 different scan positions, which then we can do this in degree of automation, but those scans need to be positioned together to form this overall representation of our space. We're a little bit more accurate when we come to tripod-based scanning because we are sat still, so that, you know, there's less variables to play with when we're talking about the accuracy, but there's a trade-off with that, and that is the processing and actually the actual data capture time out on site. When we look at mobile scanning in comparison, we're far faster. So that speed and that access means that we can go into more spaces, we can cover ground more quickly, which in certain applications obviously is quite crucial. Being able to get in and out, we don't want to be too disruptive when we're capturing and going into, say, residential or office spaces. We do, with that speed, we do obviously compromise a little bit on the accuracy, but not in, you know, it's not a significant amount. We're sort of in the region of, you know, 5 to 10 millimeters on the local accuracy and 1 to 3 centimeters, and that's versus probably sort of 2 to 5 mil, depending on which application, which hardware sensor you're using from a tripod base. But obviously that global accuracy is a little bit lower overall. But a very, very strong offering, you know, in terms of speed versus accuracy. In my many years of laser scanning, we've always had that that compromise or that degree of where do we focus our efforts on? Is it the amount of data we're capturing? Is it how long we've taken to capture that data? Is it the resolution we're capturing at? And is it, you know, the accuracy of that resultant data set? And there's many factors that go into all of those that we have to weigh up to find the best solution. And there is no one tool fits all. And that's increasingly what we're seeing in the market is sort of hybrid data sets. So being able to combine your GeoSLAM data set, your mobile data set with tripod-based systems, with survey networks, with GNSS. And all of that gives you a robust offering and a robust deliverable back to your clients. So from a GeoSLAM perspective, we've got the Z family of scanners. And the focus really is from GeoSLAM is in this. We do our data capture, we process out that data in GeoSLAM Connect. We can view and obviously make sure that we're happy with that data set and the accuracy and the tolerances are there. And then essentially we can also start to look at then creating deliverables both within the GeoSLAM family with GeoSLAM Draw, but more importantly, and this is key for me really, is that as hardware maturity has happened within the scanning technology market, software maturity has been a bit of a lack. But we're at a point now where hardware technology is stable. We've come an awful long way since that commercialization process happened in the early 2000s to where we are now. Software is really starting to be key, and with so many more people using point cloud data and with lots of different software offerings, essentially GeoSLAM will make that data available to go into your application. I'm a strong believer of not reinventing the wheel with the customer. So if they already have an established methodology and workflow in terms of downstream CAD package, then we will do our best to get the data that we're capturing into that package for them to work with more efficiently. Proves your return on investment if I'm not teaching you how to use a whole different software platform when you can do that in your existing software. So as I mentioned earlier, we've got two main scanners that we work with here in the UK market. We've got the Revo RT, which is a slightly shorter range solution, a slightly lower density on our point cloud, but perfect for doing indoor mapping, small residential projects, that sort of floor plans, net internal area, used in conjunction with some of the accessories. We've got a really solid solution for that transition from maybe, dare I say it, sketching on site or using distos and tape measures and things like that. Very, very rapid to go in and capture, but giving you good quality, accurate data to work with. And then the sister scanner to the ZEB Revo is the Horizon, which is, as they class it, the ultimate mobile mapping tool. Much longer range. We're capturing data up to 100 meters from your walk line. You've got multi-application in terms of how we can use that. We can backpack mount it. We can mount it on a UAV, on an M300 drone. We can mount it on a vehicle, as well as obviously just use normal handheld application. So with all those different accessories, we've obviously got robustness in how we can approach a project. A complementary accessory for the Horizon was the launch of the ZEB Vision. Matt spoke a little bit earlier about photogrammetry applications, and we've sort of transitioned almost away a little bit from photogrammetry into the world of LiDAR. And actually, we're seeing that photogrammetry information and 360 photos and spherical imagery actually now coming back into play quite heavily with LiDAR data as underpinning it almost. So the addition of this 360 camera option to the Horizon, which was June last year, has been really exciting for us, and we're seeing people interacting with their data differently, having bubble views of the point cloud, being able to very quickly take that and digitize both from the image itself as well as from the point cloud data, and make sure very rapid in terms of turnaround of office deliverables. And then when we look at the accessories, so I said there's lots of different ways we can use the technology depending on what type of project. So using an extension pole can get you into confined spaces, down manholes, with additions of pano cameras, either through the Vision for the Horizon or from the pano for the Revo. We've got that addition of spherical imagery. So as we said, that accessibility of data is key. The easier you can work with your data, or the easier we can make data to work with, more people will start to use it and be able to interface with it and get more information out of it. And we've also got, for larger mapping projects, the ability to run the sensors in conjunction with a GNSS receiver, so with GPS systems. So great for environments where we may not have geometry to work with our SLAM, but we can still control that SLAM trajectory using GPS positioning technology. And then when we start to think about, well, what can we do with point cloud data? You know, the technology itself for the actual capture process is straightforward. We can capture data very simply, quickly, easily. The key then is what we do with that data, and making sure that both the data that we capture is relevant for what we're needing. As Chris said in his presentation, you know, data is this huge new resource that is actually a fantastic resource, but it also has its challenges. We can get incredibly data heavy point clouds where we've got too much information. So we've got to be able to have tools within the software that allow us to manage that heaviness in the data, make it accessible, make it transferable from one data format to another, make it transferable from one software platform to another. So the GeoSLAM Connect platform is there really as that transition from your raw data to preparing it to be able to then take into these third-party applications. So the GeoSLAM Beam is the key thing that we mentioned. So we've got this very strong algorithm which allows us to process quite complicated data. And that there is this unraveling process. So the handheld technology, being able to wander in and out of spaces, making sure we get visibility is obviously key from that. We can optimize. So this was quite a new feature with the software in terms of, depending on how you've captured your data, either the application, but also then the environment that you've captured your data in. We've optimized the algorithm so that we can be confident that the way we're processing that data is correct, and we're using the correct data. We're using enough of that point cloud that we've captured. So be it either a confined space algorithm or a tree-based, forest algorithm, or even on the UAV. So lots of different ways we can work with our data. And then we do also fit into that survey workflow, and this is key when we're linking into existing site control from a construction verification perspective, but also from a multi-sensor. We've got to be able to link into a larger site network or a global network of information, and we can do that very simply using what we call a stop-go georeferencing routine, where we capture commonality, common points that can be transformed into a site grid, be it local or, like I say, OS grid. And then the next key thing is this automation of cleaning of data. And this was a really big thing with data. Obviously, we're capturing information in potentially busy offices, congested road spaces where there's vehicles and pedestrians and other moving objects. So being able to start now cleaning our point cloud data is quite key for us. So being able to remove those unwanted points where there's noise and stripes and noise in the data, being able to clean up mobile data. So mobile data does have, like all data, like all LiDAR data, does have a degree of noise in there. So we want to try and make that, clean those point clouds so they're sharp, crisp and easy to work with. And also when we start to apply the 360 imagery, we want the cleanest data to be able to put those RGB points onto. So the filtering has made a huge difference in terms of the quality of GeoSLAM data. This little video will show the difference that we can see between that transient filter search, moving object filter. So it made a huge difference. And the key thing with GeoSLAM is that their strong focus is very much in that hardware technology, the complexity of that GeoSLAM algorithm to make the data processes as robust as possible. But then at that point, we'd like to hand over. Like I say, we don't want to reinvent the wheel. There are offerings from GeoSLAM in terms of GeoSLAM Draw for doing 2D and 3D extractions from the point cloud data, but we also have a huge network of partners that we work with that will be able to take in GeoSLAM data. And that's key for us. You know, we want to be able to make point cloud data accessible. The more people who can interface with it, the more people will use the technology. And it's a really, really fantastic platform for working with. LiDAR does give you huge opportunity and we're seeing uptake of use in a whole different range of applications, be it, as I said, from MOD-based applications, from in specialist search teams, through to we do an awful lot of work with Forestry Commission, universities who are in that geography space, so understanding carbon contents of trees and that type of thing, but as well as general sort of space planning, lease, net internal areas and things like that, and then your plans for your architect and design who were wanting to obviously look at doing renovations and redevelopments of spaces. But GeoSLAM, the technology itself came out of a CSIRO grant, and mining and quarrying the underground market was actually quite a big sort of opportunity space for GeoSLAM to operate in. So being able to have that underground mapping capabilities, either autonomously by drone mounting it or vehicle mounting it for remote access, has become quite key. So we do partner with quite a few of the mining industry, so DESIC and obviously Micromine and the likes of that. So yeah, it's an interesting sort of diversion away from the traditional way of capturing LiDAR data, and like I say, the pure volume of space that you can capture so quickly, maintaining that a relative accuracy that's required for a lot of projects is absolutely key. But for us, we will see, I think, in the future, this sort of integration between tripod-based systems and mobile systems much stronger than it is currently. But I think that's certainly the adoption line that we're seeing people going along. Okay, and that's me done. So I shall pass the presenter baton over.
Thank you, Charlie. Note to say that DJI drones are also available from Surveytech. So if you do want to mount your GeoSLAM on a drone, we can help with that integrated solution. And hopefully at some point we'll be able to, as you say, mix the tripod and the SLAM data even more. And I think integrating data sets and things is definitely something that we all look forward to more in the future.